Hi, welcome back to Calculus, section 3.1 today, tangents and the derivative at a point. So we're going to get into one of the more fundamental ideas in calculus. We did limits in chapter 2, now we're going to get into what are called derivatives, and they're fun. They have a lot of really interesting uses, and so we'll see what you think about them. So let's start off with the definition, and I have kind of a picture over here that I'm going to show you here in just a second. And then we'll get into a few examples. And actually, this section is not terribly long, so hopefully I can fit it all in one video. All right, so the definition. The slope of a curve, y equal to f of x, at a point P with an x-coordinate of x sub 0 and y-coordinate of f of x sub 0. So we have a function, we're plugging in an x value, and we have a function value. Is the number m equal to the limit as h goes to 0 of f of x sub 0 plus h minus f of x sub 0, all divided by h, provided the limit exists. The tangent line to the curve at P is the line through P with slope m. Okay, so here's kind of what we're looking at. So here's my x sub 0, you can kind of see it down here at the bottom, and it's got a point associated with it. What we're trying to get to is we're trying to get to this tangent line. Okay, and tangent, lines all have slopes, so that's the first part of this. The slope of that is this limit, So what we're going to do is we have our 2 points, because normally it takes 2 points to make a line. You need 2 points to find the slope of a line. And so my second point is x sub 0 plus h, where h is just a small number, and notice what we're going to do to it. We're going to send it down to 0. So we're going to start dragging these 2 points together. So we start with a secant line, but as this point here on the right kind of drags in towards the first point, and then we just take that limit as the 2 points move together, we get the slope of the curve right at x sub 0. The tangent line then is the line that's going to have that slope and actually goes through the point. So the point slope form of a line will come in really handy when we try and write equations for tangent lines. And we'll see that maybe here in just a little bit. So let's dive in. Let's find some slopes of curves. And some of them are really pretty straightforward. Some of them are a complete utter disaster, so you're going to have a lot of fun. All right, let me get a new board. All right, let's look at my first example. So this one's actually fairly straightforward, but as you're going to see, straightforward does not necessarily mean pretty. So let's find the slope of the curve, y equal to f of x equal to x squared minus 3x at the point 4, 4. I want to write an equation then for the tangent line at the point, and this is for later. So the first thing I'm going to say is, let's get rid of this 5 for just a second. The tangent line, I'm actually going to start there because it's basically already done. We just need the slope. That's the only thing we have to fill in. And so remember, it's a point slope form says y minus the y coordinate of the point is equal to the slope, which is what we're going to find and fill in here, times x minus the x coordinate. So I've already got that set up and ready to go. You can see over there my slope does end up being 5, so I'll go ahead and fill that in. But let's see where that 5 actually comes from. So we know, yeah, this is a mess, so try and keep up. Feel free to pause, write a whole bunch of stuff down, and then come back and listen to the rest of it. We know what we need to do. We need to find the limit as h goes to 0 of f of 4 plus h minus f of 4 all over h. Why 4? Because that's the x-coordinate of my point where we're trying to find this slope. Okay, so that's the setup here. Now you'll notice that before I started working on this limit, I simplified both f of 4 plus h and f of 4. Okay, so I did the work to simplify those expressions as much as I could before jumping into this limit. This limit has enough mess going on its own. We don't need to try and do the algebra or all this algebra in the middle of the calculus. So do yourself a favor, figure those 2 bits out first. You can see here f of 4 plus h, I just plugged in 4 plus h in place of x. When I square the 4 plus h, I get 16 plus 8h plus h squared. Be really careful with your squares. And then I have a minus 12 and a minus 3h. So that whole piece simplified down to h squared plus 5h plus 4. The f of 4, that's nice. We just plug in 4 into our function, and we get 16 minus 12, which is 4. So for my limit, I'm taking this limit, I'm going to plug in those things I just found, the h squared plus 5h plus 4, and then the minus 4. And importantly, stuff starts to go away. Okay? We can't take this limit yet because we have this h on the bottom, and that's no good, right? You can't take the limit when you're trying to divide by 0. That's just not something we can do. So the 4's go away, which leaves me with the limit as h goes to 0 of h squared plus 5h over h. And so we're making progress. I notice that both terms on the top have an h, so it factors out. I wrote it as h times h plus 5 over h, which allowed me to cancel the h's. So then I can evaluate the limit, right? This is a limit that we can evaluate. Now we can plug in 0 without blowing it up. So we plug it in, 0 plus 5 is 5, so my limit is just 5, and that's where that slope came from. Now importantly, this is only the slope of this curve at the point 44. Other points would have other slopes. So yeah, this is one very specific slope at one very specific point. Let's do another example. All right, continuing on with our calculus, let's do this example. Here it is. That's the whole example, so this is going to be fun. Let's find the slope of the curve y equal to f of x equal to 1 over x cubed at the ordered pair -2, -1/8. Well, f of -2 is actually -1/8. I plugged it in. I don't know why I bothered. It's right there. F of -2 is -1/8, and f of -2 plus h is 1 over -2 plus h cubed. Now I'm going to talk, and I'm going to post another video where I talk about how to expand cubes and fourth powers and such. There is a trick to it that makes it a lot easier, and so we'll go watch that video. All right, so here's where we have to set up. We have the limit as h goes to 0 of f of -2 plus h minus f of -2 all over h. Okay, so now we get to have a lot of fun with fractions. So I need a common denominator. First, let's just notice that the minus and the negative cancel out, so this is really a plus 1/8. That's going to make things a little bit nicer. My common denominator then is 8 and the -2 plus h cubed. So the first fraction has to be multiplied by 8 over 8 because I'm going to try and put these together. So I get 8 over 8 times that -2 plus h cubed. And the second fraction has to be multiplied by the -2 plus h cubed over itself, giving us -2 plus h cubed over 8 times -2 plus h cubed. And it's still all over h. Loads of fun. All right, so that's equal to the limit as h goes to 0 of this mess. So what do we have? Oops, I lost something. No, I didn't. Okay, good. Thought I lost something in there for a second. The first thing that I did here, and yeah, this is a mess. The first thing I did is I brought this h into the rest of the denominator. Okay, dividing by h is the same as multiplying by 1 over h. So if you think about this mess as all being multiplied by 1 over h, that's where this h is coming from here. So I have 8h and -2 plus h cubed. That's my denominator because these were common denominators, and I'm just going to put the h in both of those. All right, on the top, then we have 8 plus, and we have to expand these parentheses. So again, I'm going to give you a real quick little video to show you how to do that. If you haven't already watched that, I'll actually post that one first. So anyway, we get -2 cubed plus -2 squared times h plus -2 times h to the second plus h cubed. And so there's a real nice pattern there. Again, watch the other video. Cleaning it up, we now have the limit as h goes to 0, 8 plus -8 plus 4h minus 2h squared plus h cubed, which is nice because now those 8's drop out. So I hope your algebra skills are really, really good because you're going to have a lot of messes going on. So the 8's drop out. We're left with this. The limit as h goes to 0 of 4h minus 2h squared plus h cubed all over 8h times -2 plus h cubed. Now, the top has an h in common, so I can factor that out, which allows me to cancel that h on the bottom. And that gets me here to the limit as h goes to 0 of just 4 minus 2h plus h squared all over 8 times -2 plus h cubed. Notice h is still in the denominator, but it doesn't make 0 anymore. If you plug in 0 for h, you get -2 plus 0. You just get a -2 there, and that's not a problem. We can divide by what we're going to get here. So now we can just plug in that 0, right? We know that for limits, basically if we can plug in the number, we can just go ahead and do that. So I plug in the 0, these two terms disappear, I'm left with the 4, and then, oops, that should be positive 8, whoopsie. We get 4 over 8 times negative 2 to the third, which is still negative 64, and it all reduces down to negative 1 over 16. So that's a big ugly mess. Again, watch the other video on expanding these powers, and that'll help out a little bit. All right, I just have one more last little bit to talk about, and then this video will be done. All right, so to close up this section, we've already basically talked about everything that we need, but we have just one definition left. Welcome to the derivative. Definition, f, and this is a prime. It's just a little tick mark up there. It's notation that we use, and it's going to be the derivative at a point. F prime of x sub 0, so this is, remember, an actual number, is equal to the limit as h goes to 0, f of x sub 0 plus h minus f of x sub 0 all divided by h. So we have been taking derivatives at a point in this section. So we can say 4 things then. F prime of x sub 0 is the slope of the graph at that point. F prime of x sub 0 is the slope of the tangent line. So, that tangent line that we talked about at that same point. F prime of x sub 0 is the rate of change of f of x at x sub 0. So it's how fast things are changing. That would be like the speed of a car. So this is the, if you're thinking about driving a car and, you speed up and you slow down, the derivative at a point would be how fast you're going at just an instant. In other words, how fast are you going when the police officer points his radar gun at you and says, oh, they're going really fast. And finally, this is called the derivative, f prime of x sub 0 at a point. So the derivative, all 4 of these are the same, so the derivative and the slope of the graph are the same thing. And that's just going to be super fun, and we're going to have a lot of fun with that. So thanks for coming. Have a wonderful day.